Nowadays, electric vehicles use these all-in-one controllers. So what's inside? Let's take it apart and take a look. Before we get into the internals, let's first check the appearance. Here are two water pipe connectors, obviously for liquid cooling. This is the fast charging interface with positive and negative connectors. This part supplies power to the drive motor through the UVW 3-phase connector. Next, here's the 14 volts output, which charges the small battery. This is a low-voltage power supply terminal. This is for the slow charging interface. Here's the fast charging control and another low-voltage connector. This one powers the PTC heater, and this one supplies power to the compressor. This connects to the high-voltage battery pack, both positive and negative. When the battery pack is powered, it sends high-voltage DC to distribute power. This all-in-one controller, as the name suggests, combines multiple modules. Let's start with this fast charging interface. When fast charging, the power from the charger comes through these wires. This power flows into two fast charging contactors or relays. Once powered, the contacts inside close, allowing the current to flow. The current continues through the copper busbar to the battery, enabling fast charging. When the vehicle is powered on, the battery's current flows through here. It then reaches the high-voltage fuse and is distributed to other units. This black component is the bus capacitor, also known as a supercapacitor. It helps stabilize the voltage as the electric current flows through. The power stored in the capacitor is delivered to the motor controller. If we open up the motor controller, we find two boards inside. The top board is the low-voltage control board, and the bottom one is the drive board. The drive board has multiple IGBT modules that switch power at high frequencies. High temperatures build up fast, so this board is water-cooled. The high-voltage and low-voltage boards are isolated by metal plates for safety. The high-voltage DC is converted on the drive board into UV3-phase current. Each phase is equipped with a current sensor to monitor the power usage. We also have some fine wires for interlock monitoring to ensure safe connections. Moving on, this area is the DC-DC converter module. It charges the small battery, similar to a generator in traditional cars. Above this is the PTC heating plate control board. This board controls power to the PTC heating elements. The PTC board has 3 power lines, allowing for 3 heating levels. Next, we have the onboard charger OBC module. It charges the battery with 220 volts AC power and then converts it to 300 volts to 500 volts DC power. It's important to filter out interference from the power grid and vehicle. The most common failure in this system is the power semiconductors overheating. I have one here that's burned out and failed. In electric vehicle repair, it's all about fixing these circuit boards. If you're interested in improving your skills, follow my account for more updates.